Aisha, what are you doing?
Oh, I'm studying about magnetic force and the moving charge.
Can you explain about it?
Oh, sure. Magnetic force is a fundamental force of nature that acts between magnetic materials and moving electric charge. It is also responsible for the interaction between moving charge and magnetic field. Magnetic force happens at two conditions. First, when there are moving electric charge, which is electric current, it will produce magnetic field. And second, there are moving charge response to the magnetic field. Thus, it will experience a magnetic force. Allah has mentioned in Al-Quran in Surah Al-Hadid, verse 25, "And we brought forth iron wherein is mighty power in matters of war, as well as many benefits for mankind." Now, let's take a look at demonstration.
Hello everyone! We are going to show you the demonstration of magnetic force on a moving charge by using our self-made mocha.
So, without further ado, let's get started.
First, these are the materials that we use for our mocha.
These balls are representing south pole of the magnet,
Meanwhile, the other one represents the north pole of the magnet.
and the ball right here is an object that carries positive charge.
When we place these two magnets near one another, it produces magnetic field in this direction.
Then, the charge particle enters the magnetic field region and it will produce magnetic force.
Magnetic force on the particle is directed out of the page.
How do you figure this out?
That's easy. By using Fleming right hand rule. Do you remember what does each fingers represent?
Yes! The thumb represents magnetic force F, the index finger represents velocity, and middle finger represents magnetic field strength V. This finger always has to be perpendicular to both V and B, right? Like this.
That's absolutely true. As we already know, the direction of V is moving forward, while B is pointing to the left, so thumb shows that the magnetic force directed out of the page. And that's how we will use on the Fleming right hand rule to determine the direction.
Now, let's move on to the formula and calculation part.
Okay, when a test charge Q moving with a velocity V enters a magnetic field of strength that is produced from electric current, it will experience a magnetic force. Remember that the magnetic force is proportional to the magnitude of charge, magnitude of velocity, and the strength of magnetic field. Magnetic force is a vector, so magnitude of the magnetic force can be calculated by formula F equal to QVB sin theta, where angle theta is between direction of motion V and magnetic field.
We can represent it with a free body diagram where F will be at y-axis, B at x-axis, and V at z-axis, where F must always 90 degree with B and V, just like this graph.
To give a better view, let's answer a question. Now, we give values to the variables. Strength of magnetic field B equal to 3 Tesla, magnitude of the velocity V equal to 7 as per negative 90, and Q, magnitude of charges, depends if the question state the value. If not, this differences value equal to 1.6 exponent negative 19. Now, substitute the value into the formula. The value of F is positive means the direction is going upward, meanwhile if the amount is negative means it went downward. And the force will be 3.46 exponent negative 57 Newton.